Hello guys, I'm so excited to share this video with you once again. And today we are going to be talking about the C programming language. More specifically, we are going to talk about your 0x0 Hello World project in C. Try to simplify C to the best of my ability, to simplify this project to the best of my ability. So you want to pay attention to every detail we'll be talking about here so that you understand every bit of what we've done. Would start from the very scratch, which is the quiz question, and then we'll move over to the tasks. We'll talk about Betsy a little, and then we'll be able to answer all the questions. So let's get started. For our quiz questions, the first one says, in which category does the C programming language belong? And the C programming language is a compiled language. So it makes this option the first. For our question one, what is the common extension for a C source file? The common extension is .c for a C source file, and the common extension for a C header file is .h here. Which command can be used to compile a C source file? The command is gcc. That is our compiler. And in question 4, which of the following are both valid comment syntaxes in ANSI C and Betty complaints? Well, this one here and this fourth one. Both are valid in ANSI C and both are Betty compliant. The question 5 says, what are the different steps to form an executable file from C source code? Well, they are preprocessing, compilation, assembly, and linking. All the answers to these quiz questions can be found in your resources. So you want to go through it on your own and understand it better. To start this Hello World project, we are going to create a new repository on GitHub. And that repository is called ALX Low Level Programming. So the first thing we want to do is to go to GitHub now and create this repository called ALX Low Level Programming. After which, we are going to clone it just the way you did with your ALX System Engineering DevOps. And then we can start working on everything we need. Once again, the first step to start C programming is to create our repo ALX Low Level Programming on GitHub. So I'm going to copy this now, come to GitHub here, and you should see this when you open your GitHub accounts. Just click on new and you could put the repository name. So I'm going to paste what I have, ALX Low Level Programming, come down and click on create repository. Now that's all we need. Now we have to clone this repository to our terminal, and you would use your personal access token to clone it. So to do that, we are going to use our personal access token. If you have your personal access token already, you can use it. But for this task, I will be generating a new one. And to do that, I would come to settings on the top right corner here. I'm going to click on my profile, come down to settings, scroll down to developer settings, as you can see, then personal access tokens. So I'm going to generate a new token now, and this token I'm going to name it ALX Low Level Programming. To ensure that I don't have issues in the future, I'm going to set this expiration date to no expiration at all. This is not recommended though, but I'm going to set it to this way anyways. Now you want to make sure that this first box is checked. This first box that talks about repo. It's very important. Every other box, you could check it or not, but that first one is a must. and then I should click on generate token. Now this is my personal access token here, and I'm going to copy it. I'll come here to Notepad or any other safe place you have on your computer and paste your personal access token there, because after now you won't have it again here. After doing this, I can simply go back to my repository now, my ALX low-level programming repo I just created, and this is what you should see. Now you want to copy this too by clicking on this button here, copy it, and also paste it on your notepad or wherever. If you remember, the command to clone is git clone. And so we want to clone this repo now that we've created on GitHub to our local terminal. To do that, we are going to use our personal access token. Now, after the // we are going to put a @sign. This sign here, we are going to put it. And then copy your personal access token and paste it in between. You can see I'm going to paste this in between this / and then this @sign here. So I've pasted it now, and you can see everything I need to clone here is done. My personal access token, my GitHub username, and the name of the repo I'm going to clone. So I'm going to copy all of this now and go to my sandbox or my terminal, as the case may be, and then paste it. So I've pasted it on my terminal and press enter. It should give you this message: cloning into ALX low level, you appear to have cloned an empty repository. If you have this same message, then you've done the right thing. Now we can list out what we have here to validate our repo that we just cloned from GitHub, and you can see it here, ALX low level programming. Now I want to seed into ALX low level programming, and in here I'm going to go back to the tax requirement to see the next thing I have to do. Now we've created this repository, and if you go up, you can see in your tax requirements here that for this C project, there should be a README at the roots of the repository containing the description of the repository. And the second thing we have to do is create another readme.md file at the root of the folder of this project. So what does this mean? In the root of our repo, remember our repo is ALX system low-level engineering, low-level programming. So at the root of this repo, we are going to create a readme.md file. So I'm going to copy this, come back to my terminal here, and I'm going to use vi to create my readme.md file so I can write into it. And this readme.md file should contain a description of the repository. So the repository name is C Hello World, ALX low level engineering. So you could write a detailed description of the repository, or could just write anything that you feel is a good description of the repository. For me, I'm just going to name it C Hello World. And I can now save and quit from VI. When I list out what I have in my ALX low-level programming repo, you can now see that I have a readme.md file. Going back to the instructions, we are to create another readme.md file at the roots of the folder of this project. So what is the folder of this project? If you come to your tag 0, you can see the directory or folder of this project. It's 0x00 hello world. So directory simply means folder. And so we have to create this directory or this folder next. And I'm going to use the make directory command to create it. mkdir room. So this is the command I used to create it here. Now, when you list out what you have, you can now see I have 0x0 hello world folder and then a readme.md file. Next up, everything we are going to do for this project, C hello world, is going to be inside our hello world folder. But currently, we are in our ALX low-level programming folder. So what we have to do next is to cd into our 0x0 hello world folder, and to do that we are going to just simply cd space 0 and then press your tab key, or you could go on and write it in a long format like this. Now I'm going to press enter, and here now I would create my second readme.md file describing what each script or each task is going to do. So you could go ahead to write a detailed description, but for me, I'm just going to put in my tag 0. You could go on and copy all your tags, tags 1, tags 2, just a detailed description of what that folder actually does. So I'm going to save now and quit from here. When I list out what I have, you can see I have a readme file inside my 0x0 hello world folder, and then I have another readme file inside my ALX low-level programming folder. I hope that's clear. Now, this is all the requirements we need to get started with C programming. You don't have to install Betty because you're using the sandbox, or even if you're using the SSH method, you don't have to install Betty. So for most part of it, 95% of us don't have to install Betty. And I guess you watching this video now do not have to install Betty. Betty is already installed. So you could just skip all of these steps. All of these steps, you could just skip it because you don't have to install Betty. So with that in mind, let's go ahead to start creating the files. Now our file 0 is preprocessor. And so we could create all of these files individually, but that would take a whole lot of time. So what I'm going to be showing you now is a method to create all the files using just one command. I'm going to come to my notepad here and create all of these files using one command. The command to create a file is touch. Now to create all of our files using one command, all you just have to do is separate each file with a space. I'm going to show you that now. So this is file 0. I'll come down here to file 1. I'm going to copy it, paste it, go to file 2, copy it from here, paste it, go to file 3, copy it, paste it, go back to file 4, file 5. So I'm going to do that for all of the mandatory tasks. I'm going to create all the files in one command and then come back to file 6. Paste it. So now what do we have? This command touch creates files for us, but we are going to create file 0, 1, 2, 3, 4, 5, 6 in just one command. All we have to do is after 0 put a space, and then put file 1, put a space, and then put file 2. So when we do this, we can create all the files we need using just this command. So I'm going to copy it from here now, come to my terminal and paste it. When I press enter and you list out what you have, you can see that you have all the files you need. 0, 1, 2, 3, 4, 5, 6. You can see you have everything you need using just this one command. Part of the requirements for this task is that we make all our script executable. So you can do that by simply chmod a plus x and use the asterisk here. This would make all your script executable in just one command. So I press enter. Now, when you list out what you have, you can see that every of your scripts are executable using just this one command. So you've learned two things: how to create multiple files with one command, and how to make all your script executable using one command. So we don't have to make any of our script executable again because we've done that for all our files. Once again, this is all you need, and now it's time for us to start writing the answers to the tasks. So I'm going to clear my terminal now, and let's go back to question 0. Write a script that runs a C file through the preprocessor and save the result into another file. Now, this is a script. So what we are simply doing is that we are still in shell scripting. The shell project still continues inside C. So for tag 0, this is shell. We are not going to be doing anything with C just yet. Rather, we'll be writing a shell script that runs a C file through the preprocessor and save the results into another file. Now, the C file name will be saved in the variable C file, and the output should be saved in the file C. So how do we do this? I'm going to come to my VI now. Remember, this is a shell script. And for our requirements, so you always want to check your requirements time and again to know what you're supposed to do. All our shell scripts, if you note, yes, it's shell scripts, should be 2 lines long, should end with a new line, and should start with this command. So I'm going to copy this command now and paste it somewhere so that anytime I need it, I could just go here and copy it. And so for this tag 0, the first line is going to be bin bash. You're already used to this by now. And in our second line, that's where we'll write the answer. Note the question. A script that runs a C file through the preprocessor and save the result into another file. To run a C file through the preprocessor, we are going to use the gcc command, and it's going to save the results into another file. The file that it's going to save the results into is this here. It's saved in the variable C file. It's given to us by ALX. So I'm going to copy this now and paste it. So what is the command to run a C file through the preprocessor and save it into another file? The command to run a C file through the preprocessor is -e with capital letter and then space -o. The output should be saved in the file C. So I'm going to add this C now here. Just in case you're wondering how I knew this command, this -e and -o, it's not rocket science. If you come here to your gcc.gnu.org, this website here, and especially this web page, I'm going to be attaching the link in the description below. You can see different GCC options here. Now look at one, the dash E. It would stop after the pre-processing stage. So look at it. It says run a file through the preprocessor. And here we just learned that the GCC-E option stops the file after the pre-processing stage. So this is how I got the answer. And then see the dash O, place the primary outputs in a file. Okay, and here it says we should save the result into another file. So it's not rocket science. This GCC manual, you want to go through it. Once again, check the link below of this video and you would see the link to this page. Read it and understand it. And please, as you're checking the link below, if you have not already subscribed to my channel, kindly subscribe. So this is it for the tax 0. Now I can save and exit VI and move over to tax 1. But just to be sure that we did the correct thing, rather than moving over to tax 1, just like that, I'm going to add commit and push. So git add, git commit with a message. Let's say tax 0 as our message. And then, oh, I did git instead of git. And then git push. So you can see it didn't ask us to input a password. It didn't ask for a username. And the reason is simple, because we use our personal access token to clone. So I've pushed my work to GitHub now, and I can simply go to my terminal to check if my answer is correct. So when I check code, it tells me congratulations, everything done. So if you follow this video, you should be able to do tax 0 successfully. Now let's go to our tax 1. Once again, I've just shown you the way to get the answers to these questions, these script questions. You can use your GCC GNU manual. This is the online documentation for every GCC, command. So any command that we are going to be doing that involves GCC, this documentation can help you so much. Once again, make our time to read and understand it. Now let's go to tax 1. It says write a script that compiles a C file but does not link. And the C file name will be saved in the variable C file, and the output file should be the same name as the C file but with the extension .o rather than .c. So to create a C file that compiles but does not link and save it in the variable C file, all we have to do is GCC-C. So let's do that now. Tax 1, compiler. Remember, our first line is always going to be this. If you don't put your first line at this, you're going to experience errors. So first line, bin bash. Now second line, GCC-C, and then C file. Once again, to know why this command is so, refer to the GCC documentation that is online. Now I can save and quit. I could go ahead to git add, git commit, and git push. So I'm going to do that now. Git commit tax 1 and push. All right, now we can check our code and move over to. So once again, it's successful. Now we can move over to tax 2. Once again, we are writing a script for our tax 2. So we are still dealing with shell. and it still has to do with C. So without being told, the very first command we would have to use is GCC command, because for everything that has to do with a C code, a C compilation code, we have to use our GCC command. So let's look at the question again. Write a script that generates the assembly code of a C code and save it in an output file. The output file would be this. And so our task is to write a script that generates the assembly code of a C code. So what's the command to generate an assembly code of a C code? The command is -s. So let's go ahead and do that now in our task 2 code assembler. Remember our first line, as always, and then in our second line, we are going to do GCC -s with capital letter, and then the output file we are saving it in is C file. So I'm going to write this now, and I can save and quit. As usual, git add, commit, and push. Now you can check your code. And yes, we're done with task 2. We move over to task 3 now. That write a script that compiles a C file and create an executable named sysfun. So task 3 now, we are going to completely compile our C file and create a file called C is fun. The C file name will be saved in the variable this. All right, so to compile a C file and create an executable named sysfun, we are going to use the -o command. Once again, to understand what this does, refer to the GCC GNU official documentation. So let's go to our task 3 now. PI3 name. Our first line, as always, and for our second line, we are going to use the GCC command. Now, the command to create a file, to compile a file and create an executable name, or to create another name, is the -o command. And we are going to use sysfun. So if you wonder where I got the sysfun from, see it here. It says the executable should be named sysfun. And if you're wondering how I got this C file variable, it says the C file should be saved in the variable C file there. All right, so now I can save and quit. Once again, git add, git commit, and git push. As usual, you want to check your code to be sure what you did is correct. So I'll come here and check code, and we're done successfully. So this is all about our shell scripting for this C task. Now, if you go to task 4, from task 4, that's where we officially start C programming language. So guys, welcome once again to C programming language. Officially, we've started it. Now, how am I sure that task 4 is a C program? Task 4 says, write a C program, a C program. Now, look at other task questions. Write a script. Yes, it is write a C program. So we are now sure that what we want to do in task 4 is to write a C program. So you are going to be writing your very first line of C program now. And that program is going to print exactly this. Programming is like building a multilingual puzzle followed by a new line. We are going to use the puts function. We are not going to use the printf function. And our program should end with the value of 0. Now, this looks like a lot of work, right? We are going to try to break it down into the smallest steps we can so you can understand it. The first thing we want to do is to write a C program that will print exactly this using the puts function. So by default, the general way to print a message in C, the most popular one, is to use the printf function. But here, for this task, we are not allowed to use the printf function, so we are going to use the puts function. So let's go ahead now to see how exactly we can write this C program and use the puts function. And from here, we'll start having issues with Betty. We'll now start checking for Betty problems that our code could have. Why we've not been checking for Betty since is because we've not been writing C program. So Betty is a code indentation and a coding style for C programming language, not for shell scripting. And that's why we've not been using Betty since. But from task 4, we'll start using Betty. All right, enough of the explanation now. And let's write the C program that prints exactly this. All right, guys, I cannot be more excited to start the C programming, and let's go. VI for puts. So to write a C file, the first thing we want to do is to include our header files. And to include our header file, we use this command, include stdio.h. This is the way to include our header files. Now, our header files have some command like puts. It also have printf. It also have the main function and all of that. So if you want to use puts function or printf function or some other standard function, you have to use C default header file, which is stdio.h. Now that's what we've just done now, and then we'll press enter. Now there's something we have to do. For the Betty coding style, we have to put a description of our code always. To put a description for our code, we have to comment it out. And to comment it out, we are going to use this comment out character, this one here, a slash and then 2 asterisks. Remember when we talked about this quiz question that says, let's go back to that quiz question. Which of the following are both valid comment syntaxes in C and are both Betty compliant? So to comment out something, we have to use this syntax. You know, the slash here and then the asterisk. For multi-line comments. Now for single line comments, we can use this. But for the tags we have now, we are going to be using multi-line comments. So that's why I just pressed enter. Now, Betty would look for two things. What is the main function of our program? And what is the return value of our program? Betty is going to ask us for this thing. So what is the main function of our program and what is the return value of our program? Now, how do we know the main function of our program and the return value of our program? First, let's talk about the main function of our program. So when you come here, the C program would print exactly this. So the function of this program we want to do is to print exactly this here. So the main function of our program is to print a line of code. All right, so I could just say the main function of my program is to print a line of code using put function. So I can write in my main here. I can write in my code here, main is equal to print a line using put function. Right? So we're about to print a line of code using puts. Now that's the main function of our program. What about our return value? What's the return value? Let's go now and see it. Your program should end with the value 0. So what's our return value? 0. So I'll come here now and put the return 0. 0 means success. If our program returns 0, it means our program has succeeded. So for here, we are going to write this, and then in our return value, 0. Now we can close out our comments. And that's all we need. So once again, this is our header file, stdio.h. And then we have a main function here, and our main function, the main function of this program is to print a line of code using the put function, and our code is going to return 0. Now we've written this thing out so that it can be Betty compliant, because our Betty coding style requires us to write it, or else it's going to give us issues. Now after doing this is where we'll now come to write our main code. And the general syntax to write it is just to use the main function here, int main, and then put the parameter void, and open your curly braces. So this is called curly braces here, and now I can write puts. So we are using the puts function. All right, and puts function. Now, what are we supposed to write in our puts function? We are supposed to write this. Programming is like building a multilingual puzzle. So I'm going to copy this now. Now, to write something, using the function, we have to use a bracket. So after putting the puts, remember this puts that we are using here is already defined and known. Courtesy our standard, our stdio.h, our stdio.h header, our standard header file. It's already defined. So puts is defined there. So you don't have to worry what puts it. It's already defined by our header file. Even this code here, it's defined and read by our header file here. So to be able to write something in between the puts, we have to use a bracket. Now everything we write in between these brackets would work. But for it to work, we have to use a quotation, a double quote. So you must use the double quotes. This is the syntax. First the brackets and then the double quotes. Now you can paste whatever you need to paste down there and it's going to work. So let's paste this, copy, and then come here. We are going to paste it now. Programming is like building a multilingual puzzle. Now you end this with another double quotes and put your brackets. These double quotes do not appear when you compile this program. The double quotes will not appear if you compile this program. So, but look at what we are supposed to print. We are supposed to print one double quote. So how do we do that? Look at what we are expected to print here. Look at what we are expected to print. You know, the double quotes is here. Programming is like building a multilingual puzzle. But if we go ahead to print this, C is not going to print the double quotes. It's going to print after the double quotes. So C is not going to print these double quotes or these ones. Now, how do we solve this issue? We have what we call special characters in C. And we can use this escape. So this double quote is a special character in C. If we want to print out these double quotes now, we can use our escape key here. So this slash here means escape, you know. It tells C that this next thing that I want to print is a special character. And although normally you wouldn't print it, please print it out for me. I know what I'm doing. Right? So that's how to solve the issue. They said our code should end with a new line. When we use our put function, one advantage of the put function is that it's going to automatically end it with a new line for you. And then we can use the semicolon here. We have to use the semicolon each line of code we write. Each line of completed code. So this is what we want to print, and we have to use the semicolon here. Then I come down and I'm going to return. Remember what we asked to return? 0. So you can return 0 by simply doing this. Return the 0 in brackets and also a semicolon. You come down here and you cover your curly braces. So you started it with a curly braces here. You have to end it. Right? Once you do this, you're done. I hope to a reasonable degree you understand what I did here now. It's not looking like rocket science. If you don't understand everything, that's totally fine. Totally acceptable. So this is how to get it done. So now I can save and quit out of VI and move over to the next task. Before I move over, let me check my code. So we're going to add commit and push. So to git add, commit, push, we'll just do git add, git commit. I'm going to change my commit message. I'm going to write my first line of C. So congratulations, guys. This is your first line of C programming language, and you are now a programmer. So I'm going to push, git push. And then let's go and validate our work. Before we start celebrating, let's go and check if our code is correct. So I'm going to check now if my code is correct. And we have some checks failing. All right. And guess what, guys? We have some checks failing. And a lot of people have complained about this. Betsy coding style is failing our check. So what does this mean? Our program is successful, but Mrs. Betsy failed us. So let's go and solve Betsy. Now this will bring us to a quick discussion on how we can fix Betsy. So there was something we forgot to do. And please don't forget to do this anytime you're writing a C code. Once you are done with writing your code, use this command, Betsy, and then the name of the file to check for Betsy errors. Now, Betsy, the name of the file is 4puts. So I'm going to type Betsy here, 4puts, and then press enter. You can now see Betsy gives us an error here. Look at it, 4puts. We have an error in line 5. It says trailing white space. 1 error, 0 warnings, 11 lines check. Okay, the error says trailing white space in line 5. Okay, so let's go and fix this up now. Trailing white space. So I'm going to open my 4puts in line 5. So this is line 1 here, line 2 here, line 3 here, line 4 here, and then line 5. So it says there's a trailing white space. Now, if you watch, at this 0, after the 0, Betty does not need a space. But if you watch, we had a space, an empty space that does nothing. And Betty is complaining about that. So I'm going to remove that error now and save and quit. So I've removed the space. Now, when I run Betty again, let's see if we have an error. And it gives us no error this time, but it gives us a warning. And the warning is in line 8. It says no description found for function main. All right, so now let's go ahead and write a valid description for our function main in line 8. So first off, we had our error in line 5 and then the warning in line 8. So let's fix the warning now in line 8. So this is line 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so line 8 and all right, so it did work. Now, just in case you were wondering what I just did, so this was it. In my comments here, I was supposed to use double asterisks for Betty to understand my description of my function main, but I used a single one. So when I used a single one, Betty actually threw a warning and said it didn't understand the rest of the things I wrote here. But immediately I changed it to a double asterisk here for my comment output. It did work. So that's how you can identify Betty issues. Now, when I saved and quit now and did the Betty 4 puts, you can see it didn't return any error. It just gave me my function main. So it understands what I did now. And at this point, I can git add, commit, and push. And then git push. All right, now let's check our code again and see what we have. Now we've successfully done task 4. So yes, in our first C program, Betty actually held us hostage and we fixed it. I hope you did understand how I was able to fix the Betty problems. If you don't, in my special intense learning class, I'm going to be explaining how to step by step fix Betty issues so that your code can actually be checked correctly. Because sometimes even when the answer is correct, you wrote the proper code, without Betty, you following the Betty compilation process, your code wouldn't check. So once again, you can join us for our special intense learning class. Send me a direct message on WhatsApp or comment under this video to get to know how you join us for our special intense learning class where we'll be talking about C from the basics. Today, later with the group, I'm going to be talking about how to fix Betty issues. And from on Monday, we are going to analyze the scratch of C. Every function, the header file, the printf, and every other function we need. So you want to join us. Now in task 5, task 4 and 5 are similar. We are going to write another C program that prints exactly these lines here. And it's going to be followed by a new line. We are going to use the function printf. We are not allowed to use puts function, and our program should return 0. Our program should compile without warnings. So let's go ahead and do just that now. A lot similar to what we did in task 4. So the first thing we want to do is to include our header file. Remember, we are now writing a C. And to include our header file, we do include stdio.h. And I forgot the hash. So yeah. So this would include our header file. What's the next thing to do? I'm sure you guessed it right. We are going to actually write our description so that Betty actually allows us to go free. So what's the description for this project? First, the main function of this project or of this task is that it's going to print a C program using printf, and then our return value is, as usual, return is going to be 0. So you could check your tags to see that our return value is 0, and then I'm going to comment out these full lines now. So I've done this. So this is for Betty. Now I can go ahead to write the main program. So int main void your ID, and then use my curly braces and write this printf. So we are using the printf function this time. And remember, anything you write in between these quotes is what is going to appear. So if you forget to put these quotes, your code is not going to compile well. That's the default standard. So in between these quotes now, I'm going to just copy whatever ALX said I should put here. So I'm going to copy all of these. And then paste it here. Now, for this task, we are told to print this followed by a new line. If we use the printf character and function to get a new line, we have to use the n. So this is simply going to print out a new line. If you want to understand more about new lines, then join our special intense learning class. And from next week, I'm going to be talking extensively about all the basics you need to get started with C. We are going to talk about new lines. We are going to talk about printf and more of that. For now though, let's keep going. Now we can put our return value, which is always 0. And now we can save and quit. Now one thing we want to check for that we forgot to check for previously was Betty. So want to check if Betty is going to give us any errors, and Betty does not give us an error this time. So if you did your own and you didn't encounter an error, you want to be very, very excited because it's one of those few times when Betty will let you go for free. Now, apart from checking for errors, you can also check what this code will compile. Look, this is what your code is supposed to compile. Right? This is what your code is supposed to compile and print out the new line. So now you can check for what your code will compile. If you use this compilation message here, you could use all of this, you know. You could just copy it from here and paste it, press enter. So it has compiled, and now want to use this message next up. So what I'm doing is I'm showing you a way where this all what is written here, all these codes could actually be very helpful to you. They are not meaningless. So I'm going to copy it now and paste it to, and now you can see our output with proper grammar, but the outcome is a piece of art. All right, and that's supposed to be the output we would have. Okay, so I could also copy this and paste it here. Now, what am I expecting to get? I'm expecting to see 0. And you can see I saw 0. So I don't know if you understand what I did, but I used all these codes here to validate my answers even without checking the checker. So I'm 1000% sure if there's something like that, that when I check my codes, I'm going to actually get everything so correctly. So let's do that now. We are going to git add, commit and push, git add, git commit, start 5, and then git push. All right, now we can go check our code. So we can see it now. Congratulations. We could see how confident I was after validating my answers with this, and it also works just like that. So if you don't understand how I was able to do this and how I was able to get it, then please leave the questions in the comments below. And by joining my special intense learning class, you get detailed explanation from me about all of these things I've just explained, plus even more. So you want to send me a direct message to be able to join us as we combat C for the next 2 weeks. Now we go to question 6. Write a C program that prints the size of various types on the computer it is compiled and run upon. All right. You should produce the exact same output as in the example. Warnings are allowed. Your program should return 0. You might have to install the package this to test your program. All right. Now, you see this thing I've just explained in task 5. It's exactly what is waiting for us in task 6. Your program should produce the exact same output as in the example. Where is the example? These are the examples. All right. So by the time we finish running our program should produce the same output as in the examples. All right. So let's go ahead and do this. See the first question. Write a C program that prints the size of various types on the computer it is compiled and run on. So the C program is going to print the size of the various types. Do you know C types? Well, if you don't know about C types, that's totally fine. From next week in my special intense learning class, I would also be talking about C types. So we have a type like integer, we have character, we have double, we have floats. So all these C types, I'm going to be explaining it better from in our special intense learning class so that this video does not get too long and boring to us. For now though, let's try to code along. Now this is much more difficult than every other thing we've done. But we are here to do hard things, so let's get started. The first thing we want to do is to include our stdio.h. Next up, we want to put a description so that Betty would fill. So what's the description? Our main purpose of this program is to print out sizes of data types in C. So that's what we're about to do now, you know. And then I'm going to add something. Code by Bwave ICT. So this is what you can do when you're commenting out code. You could put anything, and then I've just put the owner of this code by Bwave ICT. Now, what will be our return value? Our return value is going to be 0. All right, and we can safely leave here now. Now, once again, I'm sure you're used to this. It's main void curly braces. Now, we want to print out different data types. The first data type we are going to print out would be an integer. The next data type we are going to print out would be a long integer. The next data type we are going to print out would be a long integer. We are now going to print a character, and we are going to print a float. I know you are wondering how I knew I'm going to print an integer first, long integer, long integer, a character, and a float. Well, let's go back. It says our output should be exactly the way it is in the example below. And see the example. We are to print a character, an integer, a long integer, a long integer, and a float. All right. So yeah, character, integer, long integer, and float. Look at what we have here. We have integer, long integer, character, and float. So we could also do this. We could also take our character to the first thing we want to print. So we could do character A, then just change this to we'll just change this to B, this other one to C, this one to D, and just keep the float at F. Now we'll come down here now. So what I've just done is that I've defined, we could call these defined variables. Now I know if this sounds a little strange, that's okay. It's supposed to sound strange. With time, you are going to understand it more. But now what I'm going to do is to print, I'm going to use the printf function now to print all of this. How do I know what to type here and the rest of it? Let's see if the question can help us. Okay, so this is what we are supposed to print. Okay, so I'm going to size of a character. I'm going to copy this and paste it. And then I'm going to use this LU. So I got questions that says what is LU used for and the rest of it. Now I don't just want to answer, because for me the most important thing is not just to answer, but to, you know, be able to show you how to get the answers on your own. So come here now, and this is what you can do. You could come here and just put what does the %sign LU mean in C? All right. Now LU stand for unsigned integer or unsigned long. What LU does is that it takes only parameters of positive values. Okay, so we can't have something of a negative value with NU. We can't have something like this using ALU because it takes only positive integers. All right, so with that now, we can continue. So the LU prints out an unsigned long. An unsigned, any unsigned value takes in a positive integer. So you could just know that for now. And then this N stands for new line character. What we could print more is this. So when we use this format specifier LU, we are going to come here and let it know that it's an unsigned long. And then we could put size of D. So size of A and great. So let me explain what this does now. Let me explain it better. The size of character we are going to print, the format specifier we are going to use is, it's not known yet. We want to know the size of this character called A, right? So the format specifier we are going to use is not known yet. And we use this LU here as a placeholder. We can use ZU, ZU, or even D as our placeholder. But in this case, we've chosen to use the LU here. And now, as our placeholder, now LU stands for unsigned value, unsigned long. Now we've told it that the size of character not known yet. Now the unsigned long should get size of A. This is A. A means character. So we are saying this value here should get the size of this value here, and this is a. The value of a is character. So unsigned long here, which we don't know now, should tell us the size of our character or size of a. I hope that's clear. Now that's the same thing we are going to do for the rest of it too. So rather than hard type it, I'm just going to copy everything we have now, and then I'm going to modify it. So I'm going to copy it, come down to the next line. Rather than hand typing everything, I'm going to paste it now. But in this case, what we are working with is size of ints. All right, we are working with the size of our integer. So I'm not going to put size of car here. I'm going to remove the car and then put ints. And then come down here, and rather than this a, I will now put b. So once again, the size of integer, unknown for now, with this value lu is, so we can say size of ints is dash bytes and then a new line. So this is what we are saying. Size of ints is dash bytes. All this long, you see all this long oh, it's broke after I tried to do that. All this whole long code that we've writing is simply trying to print this. Size of it is dash bytes. This dash now we don't know. That's why we use this LU specifier in between. So we don't know it. Now the LU stand for unsigned long. So we have to say unsigned long. We have to give it that parameter and tell it that this is an unsigned long. Now print the size of what? With the size of ints, and ints in this case, our integer is b. So this thing here, this thing, that's what we are trying to achieve now with the syntax that C can understand. So if this is clear, size of ints is dash bytes, and to get the size of the ints, we have to use our unsigned long because we use the LU here, and then put size of b. So that's what all this whole code is doing. So I hope it's a little clear now. I'm going to go ahead and print out this exact same thing and then modify it. So if it's clear, you could go on and modify the rest and without looking at this video, and let's see how you are going to do that. So size of a car, size of an int. All right, size of an int. Now size of a long int is, I'm going to come here now and then change this value to C. Now I'm going to copy this. Now, once again, I'm going to change this value now to D. The next one we are looking at is size of a long int. All right. And lastly, we are going to be looking at size of a float. So I'm going to copy all of this now, paste it down here. So I'm going to change this car here to floats. And that's that. Okay, so I hope to a reasonable degree, at least you understood what we did now. This all I need to write. So this is the answer to the question. The return value, as usual, is going to be 0, and we can close out our code with the curly braces. So this is question 6. Now there are more than one ways to do this, but this is just the way I chose. There are other ways that could be more simpler or more complicated, but this is the way I chose. And this, when we talk about format specifiers and data types, you will understand it more. So you want to watch out for when I will be talking about format specifiers and data types, especially with the intense learning class. This video is part of the intense learning class, to be precise. So you want to watch out for videos about format specifiers so that you can also understand that. Now, what I'm going to do is use Betty to check if I have any errors. And you can see I have no errors, even with those long line of codes, because everything was indented where no unnecessary white space, and everything I needed, I got it. So that's all we need. Now, you could go ahead to check your code and all of that, but let's just git add, git commit, and git push. Task 6. Come down here to and check our code and see what we've got. So all our tests pass successfully. The checker sees us correct, and we are ready for the next task. In this case, the next tasks are advanced tasks, and we are done with all the compulsory tasks in C Hello World. And for this next task, it's even a script, so it's not a C file. And then the last one is an advanced task that you have to print a C program, and your program should return 1, and then your program should compile without warnings and all of that. So, but basically this is all for the mandatory tasks. If you understand it, I think the question 7 is very simple, and 8 is not also difficult. You could go ahead to try all of that, or you could just leave it at this advanced tasks and try to understand it again and again and again and again. If you don't understand it and you feel totally lost, that's okay. In fact, that's how it's supposed to be. With time, these things will start making sense to you. If you have any questions from what we've discussed, please leave it in the comments below. If you have any contribution, anything I did that's not clear, or you have a better way of doing it, please leave it in the comments below. I will gladly want to hear from you. Thank you so much for being with me throughout this video. Please remember to like the video if you found it helpful, and subscribe. If you've learned any new thing from this tutorial of 1 hour plus, please also comment below and kindly subscribe to the channel. Thank you once again. Until some other time, it's a goodbye from me.